Metab also has some other functions to perform some further analysis in the results. So one of these functions is called remove false positives. The idea is that in metabolomics, some compounds may be found in one or two samples. From, let's see, in this example we have here, we have 5 samples from each condition. If we find a metabolite in only one of these samples, it's really difficult to say that metabolite is a true compound. So the ideal way would be to go back to the chromatogram and check in the samples where that compound was not found to see if that compound is actually there, and even check in the sample where that metabolite was identified if the identification was correct. However, we are not going to do that for every metabolite. If you want a high throughput analysis, we need to find a way to put a threshold where we consider that, for instance, we consider a true compound, a true metabolite, if we find that compound in at least 2 or 3 of the samples. At least 3 of the samples, I would say. So in this case, this function here performs this type of analysis for us automatically. So let's suppose that we have a result from this function here, met report base peak. Okay, we have this result here. So the metabolites found and the abundance in each condition, and we can see that this compound here, xylene, in this condition, it was found in only 2 of the samples. So it's a bit low. And in this condition here is even worse. It was found in only 1 of the samples. So I would say that probably this compound was a misidentification, was identified probably very similar. They have a fragmentation very similar to xylene 2. So probably they are identifying the same peak, I'm not sure. But the idea is that it was found only in 1 sample. And I don't consider that a true compound. So this function filters these results, keeping only the compounds that were found in a minimum number of samples. So our results are here in this variable here, test met report. So let's filter that report, keeping only metabolites that were found in at least 3 samples. Okay, so if you come here, remove false positives, so we are going to apply that function to this result here, test met report. Then we are going to consider here the percentage of metabolites that we consider true. Okay, so we are talking about finding metabolites in at least 3 of the samples. Okay, so it will be 3 out of 5, which gives us 0.6. So we need at least in 60% of the samples. Okay, so which will be the case for none of them. So if you put here 60% of the samples, I won't save the results for now. Let's analyze. It shows me the result here. It removed xylene 3 from the analysis because it was not present in at least 60% of the samples from each condition. So here we have less than 50% in this condition and less than 60% in this condition. Here it's present in this one, have 2 out of 5, right? So 2 out of 5 give us 0.4, right? So if I put to filter this report here in 40% of the samples, so the compound must be in at least 40% of the samples. So xylene would be present in this condition, in this first one, but it won't be present in this other condition here, right? So if you put here 40% and reanalyze, Now I have xylene here, so it's present in the first condition, but it was removed from the other condition. So now I have Na values for the second condition. Okay? So that's how we use remove false positives. And just to remind you, all of these functions you can apply without putting all the arguments. And all of them accept CSV files as well. So for instance, this one here is one result. So this is one of the results that we generated before. Testing Metabase peak. So if I want to use that file instead, I can come here and say test, remove false positives, and that's it. I can enter. It's going to ask me where the file is located, so where is the CSV file containing the input data. So in this case, the input data is that result we had before, which will be in here, example metab. That's the result that we're talking about. So I want to filter this file. So select the file, choose, and the results here already. So if I see the result, there again. So if I want to save the result, the same idea as we said before, save equal true, and or I can apply the same way we applied before. So now I can put save equal true. It's going to select to ask me where the sample, where is the input data. So the input data is the same one we used right now. So this one. Now it's going to ask me where is the folder that I want to save the results. So I want to save the results in the example metab, and it saved the file called no false. I can also define a different name if I want with the output argument. Okay, so it's no false, the file is here with the same result. So in this case, xylene is not here because we selected 40% of the samples.